Okay, so 1.3 there is so surface area. Surface area is basically the total. Oh, why is my pen so thick? Okay, of all the areas of all the surfaces combined. Okay, so it's some of you are really good at calculating surface area already. So in this case, you just need to think 3D. Okay, you just need to think 3D, and please make sure you can imagine what's at the back and what's at the front and what's at the bottom. Even though the picture does not show you one of the surfaces, you can imagine that there's something at the back you need to take into consideration. So the formula for a surface area of a rectangular prism and a cylinder is the same. Okay, so so anything that's boxy, so like rectangular box or a squarey box, okay, it's the same. So it's basically all the sides. So this side times 2 plus this side times 2 plus this side times 2, and you're done. Okay. Yeah, so if you understand the formula, you just don't have to consider the formula at all. Okay, so there are 3 dimensions there. Let's look at the first example. There are 3 dimensions there. You need top times 2, you need side times 2, you need front times 2, basically for front and back. Okay, top times 2, the top is this distance times this dimension, so you need 2 and 4. So 2 times 4 times 2. Okay, and then the side is you need 1 and you need 4 for the side. So 1 times 4 times 2. Okay, and front is basically the 2. You need the 2 and you need the here. Okay, for this. So that's a 1. Okay, and a 2. So you need 1 and 2 times 2. And you just combine them together, you get the answer. So how you calculate it? So here would be, sorry, I'm just gonna write it down. So here is 16, here is 8, here is 4. Okay, and then you add them up, you get the surface area. So 16 plus 8 plus 4 is 28. Okay, so 28, let's write down the unit. It's surface area. So it's squared. Okay, awesome. So next, surface area of the circular cylinder is basically, if you expand it, I think you've learned it in previous grade, if you expand it, it's basically a square, a circle at the top, and if you expand the side, is basically a rectangle at the bottom and a circle at the very bottom. Okay, so if you expand it, it's just like that. Okay, so just remember that remember that formula here. So it gives you R and H, but without giving you a number. So I'm just going to give you a number. In this case, let's say R equals to 2 and H equals to 4. How about that? Okay, and so let's calculate it. It's basically this area times 2 plus this area. Okay, so I'm just gonna say the circle times 2 plus the rectangle. Is all cylinders are like that. So this circle times 2, circle is pi r squared. For the area of a circle is always pi r squared. Okay, so pi r squared times 2. So pi r squared times 2, and this rectangle is always side times length times width. Okay, pi r squared, do we know r? Yes, r is equal to 2, so plug in r. Okay, w times length, width times length. So the height here, h, is 4, so that means this side length of the rectangle is 4, which is h. And do we know this length here? This length here is the same as the diameter of the circle, okay? Because it actually wraps around the circle's diameter. So it's basically the diameter of the circle. Not the diameter, sorry, circumference of the circle, okay? So circumference is basically r, 2 pi r is the circumference. So is this one here, okay? Circumference of a circle. So it's 2 pi r here. So it basically will give you 2 pi r times 4, okay? Do we know r? Yes, r is 2, so we plug it in. 2 times pi times 2 times 4 will give you the answer. And in this case, this part is 4 pi. This is a 4, okay? 4 pi times 2 is 8 pi. And then here is 2 times 2 gives you 4. 4 times 4 gives you 16, 16 pi. And you basically have to add them together. So 8 pi, these two and these two, you have to add them together. Okay? So 8 pi plus 16 pi will give you 24 pi. Okay? That will be, let's assume it's cm, centimeters squared. Okay, you can leave pi there when we say we can leave the pi, but you can also type in your calculator, say 3.14 times 24 will give you a result as well. Okay. All right, so in this case, calculating surface area of a 3D model, like a solid, okay, when a shape is actually cut out for you, a section of the shape is cut out for you. In this case, the cutout piece, you can just like, it's just like you dig out a piece of it, okay? And this part here is empty. It was supposed to be like that, okay? And now it's dig out. A small rectangle is dig out of the big. Okay, so in this case, you can actually see, you can actually like give a top view, a front view, and a side view, just times 2 for all of them. Okay, it's the same thing as the previous example. However, just think about it. It actually does not have a difference between there's no difference between the cutout before and after. So let's see, think about it. It once was like this. Okay, and this surface here is now gone, but replaced by this surface here. Do you see that? Okay, if you can think 3D right now, okay? And it's really hard to teach online in terms of 3D courses because in the classroom we have the model. So it's easier to think about, but just try your best with me, okay? Ooh, where's the... Okay. And this part was originally there, but now is gone. Replaced by what? Replaced by this part. Do you see that? So there's no loss or gain. It's one is cut out, replaced by an inner surface. Okay, so it's the same surface area as before, basically. And do you see the side? The side, which is this part that's being cut off. It's gone now. Replaced by what? Replaced by the inner surface here. Okay, so the total surface area actually did not change. So if we know that, any cutout piece is the same, okay? And the surface area won't change because it will be replaced by an inner surface. So what's the dimension of the cutout piece? Oh, dimension of the cutout piece. Okay, so they're asking us the small rectangle here. The cutout piece, okay? Dimensions is basically, because they are giving you all the dimensions already, so you can see that the top view is 8 and 16, so you can say this is 8. I'm gonna make it bigger and draw it way too small. Okay, and this is 8 here, and the long side is 16. And how about the short side here is 8 and 8, okay? So this is 8 as well. Okay, the dimension of the cutout piece. What's the total surface area of the solid? In this case, we talked about it before. It was supposed to be... Why is it jumping? Okay, it's supposed to be like that, but like for example, this surface area is replaced by surface 3, and this surface area is replaced by 4, and I'm gonna erase this part here, and the top part, which is gone, the top part here, which is gone, is replaced by 5. Okay, so it's basically the same as before. The total surface area will be the top times 2, side times 2. What do we have left? Front times 2. Okay, the top is, let's say the top is right here, and 20 times 20 by 24. Okay, 20 times 24 times 2. Side is 24, and do we know this one? Yes, 15, because it's written right here. Okay, so 15 times 24 times 2. Front, 15 by 20, and then calculate, add them up, you're done. Okay, so I think when you add them up, you can just calculate by yourself, it's fine. Okay, so yeah, basically this is what I talked about before. Did you know that if you cut out a rectangular piece out of one corner, it does not change? Okay, so basically if the corner is cut out like that, like what we did before, okay, if a corner is cut out and it turns to this, the surface area does not change. Surface area does not change. It's the same as before. You can just calculate it as assuming that the cutout piece is not cut out. But in this case, the corner is not a corner now. It's like a whole side that's cut out. Okay, when a whole side is cut out, do you see? I'm just gonna redraw the before image. See that this surface here is cut out, but it can be replaced by this. Okay, and this surface is cut out, the side, but is replaced by the inner side here. However, this side and that is forever gone. Okay, it's not replaced by any of because it's gone. So if you have a cutout piece that actually goes through the shape, the surface area does change. You just have to recalculate it. Will change when the cut is actually going through a rectangle. So which is the staircase example. Okay, in this case you just have to add all the face up together. Okay, so you need to get a top view, a side view, because if you got the top, side, and front, top, side, front, yes, you can actually times 2 to all of them and add them up together to get the whole surface area. Okay, just don't left out any surface. The top view, which is basically is this surface here and this surface here. Okay, and them adding up, if you actually redraw it, if you look at the stair from top down, okay, it will look like this. And this is actually going out, this is actually going in. This is step 1, step 2, step 1, step 2. Okay. Okay, dimensions, basically a large rectangle. You can just calculate by calculating rectangle. The bottom here, the length here, do we know that? Yes, it's 90 because it's given to you. Okay, and where else? So the side here, or the long side here, is it given to you? Yes, 80. Okay, I actually have to draw this side a little bit longer because it's 90, but yeah, it doesn't matter. So 90 and 80. So you basically do 80 times 90 times 2. Okay, that's the top and bottom view done. Okay, because the bottom is the same. The bottom is just doesn't have the split, but it's the whole rectangle. So it's the same. Yeah, we're done with the top view and the bottom view. So side view, the side is basically face 5 and face 6. Okay, in this diagram here. I'm going to highlight it. So face 5, that's the side. And face 6 there on the side. We cannot see it, okay? Basically face 5 times 2. So face 5 would be like this. I'm going to draw it out. It's going to be like this. And the dimension that tells you this is 40, that's 90, okay? But you cannot just do 40 and 90 because there's a cutout piece, okay? Now we basically what we can do is 40 times 90, which gives us the whole rectangle, and then subtract this part here. Now, do we know the dimension of that cutout part? Yes, we know, because we know that this is 60 because it's given to us, okay? We know this is 20, so it's given to us, okay? If we know that, then we can just find out the dimension of the cutout piece. So this is 90, this is 60, then what gives you this part gives you what? 30, okay? And this part is 40, this part is 20, so this part should be 20 for leftover. Okay, now we know this surface, cutout surface, is 20 times 30 basically. So you get the idea of the whole rectangle, which is 40 times 90, subtracted by the cutout piece, which is 30 times 20. That piece is cut out. Okay, just gonna highlight it. This part is cut out. Okay. All right, so this is the surface area of the side. Do we need to times 2? Yes, times 2. Okay. Yeah, surface area calculation, just lots of steps, but as long as you do it slowly, you take care of all the surfaces, you're good, okay? Because all the informations are given. So front view is face 1 here, plus face 3 here, and it will basically look like that if you just look from the front. And the back will basically look the same, okay? But without the separate line. So it's basically that times 2. All right, do we know the dimension here? Yes, it's 40. Do we know the dimension here at the bottom? Yes, it's 80. So it's basically 40 times 80 times 2. Okay, add them up and you're done. Okay, when you type into your calculator, by the way, guys, please make sure that you do bad math by yourself. Okay, so type that in, type that in, type that in, and then do the subtraction and then times 2. And then do this one and plus them up together. I'm not going to do it together with you, just as long as you get the equation right, usually you'll get the correct answer because the rest of it's just calculator work. Okay? Okay, painting a bookcase. Ooh, that's a hard one. Okay, that's not actually hard, but you need to think about it a little bit. Okay? So, potassium, okay, wants to paint the shelves and the outside of the bookcase. Okay, want to paint the shelves. So basically, I'm gonna actually highlight the part he wants to paint. So this part he wants to paint. So the shelves, okay, and this one here, outside of the bookcase. Okay, so this part plus that part plus the part at the back. Okay, so he will not paint the back. Okay, the back we don't worry about. The back is very thin. Plywood does not add any extra depth. Oh, okay. So basically, it's basically saying that the back is the plywood, so we assume the back does not exist. And then the length here is basically length here. So the length is the same. Basically, it's telling us this. What assumption could you make about how he calculates the area to be painted? Oh, assumptions. It's just that there's no add extra depth for the back plywood, so all the dimensions is the same. So A, B, C, D here, the dimensions are the same. Okay, we just imagine the perfect scenario here. Find the surface area that potassium needs to paint. Okay. All the numbers are given to us. We just have to calculate it. Okay, it's 22 here for the blue line. For all the blue lines, 22. Okay, and for all the red lines, so here is 115, here's 115, 115, 115. Okay, and I'm gonna add another color here. For 140, this is 140 here, and this is 140 as well. Okay, and that's 140 as well. So basically, this side and the back side they're the same. So yeah, I'm just going to name this A, B, C, D. I'm just gonna name it as E and F. Okay, so let's talk about it then. Basically, for all the surface area he needs to paint is basically surface A, B, C, D, E, F, adding up together. Okay, I numbered there. So A, B, C, D, you can say they are actually the same shape. You can just calculate 1 and times 4. Okay, so let's talk about how to calculate surface area 1. Surface area A times 4 basically will give you that. Area A is 115 times 22 because it's a regular like rectangular shape times 4. Okay, and that's part of the answer, plus E and F. Okay, E and F are basically the same. You just calculate area of E times 2. So area of E is 140, which is the long side. The short side is 22 times 2. Okay, you can calculate this part, and plus them together. You're done with the answer. Okay, and according to my calculation from the previous notes is this. Check if I'm right or wrong. Okay, because the equations is always the most important. So yeah, I think we are done with. Oh no, we're not done. Okay, there's another example. The more example, the merrier, actually. So estimate the outside surface area of the building. Okay, and calculate the outside surface area. Estimate, there's no use for estimate, just don't care about it. Let's just go straight ahead and calculate it. Okay, so in this case we have lots of surface here and we're gonna number them. Okay, so there's a front, which is A. Is there a back that's corresponding to it, like the back? Yes, of course. So we basically write down A times 2. So the front and back is covered. Okay, and this rectangle here, we call it B. Do we have a rectangle at the back? Sorry, not rectangle, triangle at the back that's also the same as B? Yes. So B times 2 is another one. Okay, so this is basically the front. The front is A plus B times 2, basically. Okay, and the side here, it's actually rectangle. So how? Okay, okay, A and B is covered. So let's say C here. So C is basically a rectangle too. So C, and there's another side of C at the, you cannot see it hidden here on the other side. So C times 2 covers these two surfaces too. Okay, so and if I name it D here, then D has another D on the other side. So D times 2, we need to calculate that as well. Okay, is there anything else that we need to calculate? The surface area of the building. When we calculate buildings, there's something to keep in mind, because if we calculate the building, then we assume the bottom, the floor, is not counted because it's in contact with the floor. Okay, it's in the ground. The floor is not counted. So yeah, we basically covered all the surface area here. Okay, now let's do each part. Let's calculate each part. Surface area of A, do we know? Because it's just like a rectangular shape, is 5 and 6. Okay, so 5 times 6 times 2 plus, do we know B? B is a triangle, so base times height divided by 2. So base is basically 6 here. Okay, because this part, I'm just gonna highlight this part and this part is the same length. So the base is 6 and the height is 4. Base times height, 4 times 6, 6 times 4, same thing, divided by 2. Okay, that's the triangle's surface area times 2. Okay, plus C times 2. Where is C? C is a rectangle. And do we know the dimension of the rectangle? Yes, for sure, because if that's 10, this is 10 too. Okay, so 10 and 5. So 5 times 10 times 2. That's C covered. And D is basically, the bottom is 10, the side is 5. So plus 5 times 10 times 2. Okay, and then you're done. And you don't care what's at the bottom because a floor is not counted for a building that's actually standing there. Okay, because it's covered by the ground. Okay, so just the rest of it is just calculator work. You just have to calculate them. Okay, so in this case, it's basically 22. Actually, I'm not going to calculate with you guys. Just type in your calculator these 4 groups and then add them up together. Okay, again, the equation is the most important. So, yeah, I think that's all. Thank you so much. And the homework, I will write in the description box. So homework in description box. Okay, at the bottom. All right.